What's up? Morning guys, we're going through the lactate anaerobic system today. So again, we're going back through this whole process of we run back. First of all, we start with ATP splitting, where ATP is broken down by ATPase into ADP plus P plus energy. That energy is used for muscular contractions. Now when that runs out, we need to resynthesize it. The first anaerobic system we looked at was the ATP-PC system, right, where once creatine kinase, the enzyme, detects high levels of ADP, breaks down PC into P plus C plus energy. The energy from that resynthesizes the ADP and the P together so that I can create ATP again, and then I can go through the process of splitting it. Now, we were saying that it's really, really good for high intensity movements. However, the issue is it only lasts for about 8 seconds. Okay, so if I'm in a 200 meter race lasting 16 seconds, I'm going to run out halfway through. Okay, so then I would then switch to my lactate anaerobic system. So let's have a look at some time frames first of all. First of all, we've got how long it actually provides energy for. Okay, the lactate anaerobic system is going to last up to 3 minutes. Okay, I put LAS. So the lactate anaerobic system provides energy for up to 3 minutes. Now, then it might give you a scenario where it asks for where the majority of energy is provided for. If we're talking about when it's providing the majority of energy, well, first of all, if it provides it, if there is an event lasting 4 minutes, it's still providing the majority of the energy, because 3 minutes of it would come from the lactate anaerobic system, and then 1 minute would come from the would essentially be aerobic respiration. But so if we're looking here, it can provide energy for up to, or the majority of energy, for 5 minutes and 59 seconds. Now, if it gives you a question about some kind of event, it'll make it really clear. Okay, it'll give you a time frame, and it won't be 5 minutes and 59 seconds. Okay, if it wants to know aerobic respiration, it would probably ask somewhere like an hour. It'd be asked like about a marathon. Whereas this, we have things like gymnastics routines lasting up to 90 seconds, which we'll get to in a little bit. So it provides energy actually for 3 minutes. It provides the majority of the energy for up to 5 minutes and 59 seconds. Then we need to get into how does it do that? So I've got here carbohydrates. Okay, so carbohydrates are the energy source for the lactate anaerobic system. So carbohydrates, obviously you eat them, and they are stored in the muscle as glycogen. Okay, now when I need it, glycogen is broken down. Okay, so that's broken down. That releases some energy. Okay, enough for 1 ATP. Okay, then glucose is then broken down. Enough energy again for 1 ATP. So I get 2 ATP from this. Now so I've got glycogen is broken down to glucose, then glucose is broken down to this thing called pyruvate. Now, it's called the lactate anaerobic system, which means there's no oxygen. So as a result, this pyruvate gets converted. Now just notice, these were breakdowns. This is a conversion. So it doesn't release any energy. Okay, so it converts it to lactic acid. The reason it converts it to lactic acid is because there's no O2 available at the muscle, because I'm working at too high of an intensity. Okay, so glycogen broken down to glucose. Glucose broken down to pyruvate. Pyruvate is converted to lactic acid. This whole process is known as glycolysis. Okay, this is glycolysis, so you would need to name that in your answer. Okay, fine. Now let's just compare that to here, which is, if we go back to yesterday, this is the ATP-PC system. So PC only breaks down once, so I only get 1 ATP. Now, this is faster than that. However, this provides more energy, which means that I can use it for a longer period of time. Okay, so if we're looking at advantages and disadvantages here, is it still provides a rapid breakdown. Okay, so these are still broken down really, really fast because they don't need oxygen to do it, right? Which means I can rapidly resynthesize ATP, which means the movements that I'm doing are still high intensity. So for example, a 200-meter race, if after 8 seconds you run out of creatine kinase and phosphocreatine, then I'm going to switch to this, but it doesn't necessarily mean that you travel slowly. So it's not quite as fast as the ATP-PC system. However, it still allows you to do very high intensity movements. So the advantages would be, it's a rapid breakdown. Okay, it's a rapid breakdown of glycogen and glucose, which allows for a rapid resynthesis of ATP. And the other benefit is that it lasts for 3 minutes. Okay, 3 minutes is obviously longer than the ATP-PC system. However, the issue comes in here. Okay, so lactic acid, we all know, is bad, is it produces lactic acid. Now, the issue is that denatures enzymes. Okay, so your enzymes like ATPase and creatine kinase are both denatured. What that means is that I can't break down phosphocreatine anymore. I can't break down ATP, which as a result, it causes the performer to feel fatigue. Okay, so as a result, in let's say a 400-meter race, in that last 100 meters, when lactic acid is at its highest, the performer's going to have to slow down. They might have to stop. Okay, they're not going to stop, but they're gonna lose. Likewise, if I'm a gymnast and I start to get fatigued during a tumbling routine, I'm not going to be able to jump as high, which means I can't get as high marks. Okay, so this is what the question will look like. So, explain them how the majority of energy is provided for a gymnastics tumbling routine lasting 90 seconds. Okay, now it says explain, which means it wants the process. It also says majority of energy. Then it says 90 seconds. So the majority of energy, okay, it wants the most of. So the majority of energy, would I still use phosphocreatine in a tumbling routine when trying to do a double back somersault? Yes, I would. However, I'm going to run out of that very, very quickly. And there's going to be there 82 seconds worth of energy being provided by the lactate anaerobic system. So your answer would look like this. The majority of the energy is provided by the lactate anaerobic system. Okay, this process is known as glycolysis. This is where glycogen is broken down to glucose. Glucose is broken down to pyruvate. This is then converted into lactic acid. Okay, now then it says explain, so you could say it's beneficial. So it's beneficial because it allows for a rapid breakdown of energy sources, which allows for a rapid resynthesis of ATP, and it also lasts longer than the ATP-PC system because there's more stores of it. Okay, because you don't really eat phosphocreatine other than maybe a steak, whereas carbohydrates and glycogen and glucose are very readily available. Okay, now I know it's the majority of energy there because 90 seconds is clearly longer than 15 seconds. Yeah, and we said that the ATP-PC system provides the majority of energy for up to 15 seconds, whereas this provides the majority of energy up to 5 minutes and 59 seconds. So I know that's what I would need to talk about. Also, any application would have to be to gymnastics tumbling routines.